right, let me just position this perfectly. All right, cool. So today I'm going to talk about building JavaScript tools that you might not have known it was possible for you to build. So I want to make sure that people understand a lot of the potential that's out there. So quickly, a little bit about me. I work at AddThis, so that means I do a lot of third-party JavaScript. And a shout out to my coworkers. I was not there today, obviously, and they released their new product, AddThis Pro, so shout out to them. Besides my day job as a JavaScript engineer, I do a lot of open source work. I'm going to demonstrate one of the open source projects that I've been working on the past 3 or 4 months that relates to this talk. And I try to speak as often as I can, meetups, things like that. I also wrote a short Require.js book last year, so I've been heavy into the AMD side of things. But to get started, JavaScript tools is very general, so what types of tools are we talking about? And so what I'm going to talk about today are static code analysis tools. So did anyone go to Arya's talk? The first talk of the day was in the same. Yeah, so Arya's talk, it's going to be kind of similar. He kind of made the building block, and I'm going to show you a lot of different stuff that you can do. And hopefully, you don't need to be like a genius to do this stuff at all. Arya is very smart, but you do not need to be like that. So what do these tools typically do? Static code analysis tools, they usually analyze code, whether it be code performance, it could be code maintainability, it could be just code validation. They analyze things. They can also generate code for transpilers, minifiers, visualizers, a lot of different things you can do with static code analysis. So yes, I can provide some examples of static code analysis tools that you probably have used. The first one I'm going to mention is Uglify.js. If you use Node.js as your build system, you're probably using Uglify.js. You could use Clojure compiler, you could use a bunch of other minifiers, but Uglify reduces the size of your code by minifying it and optimizing it. And it does that as it's basically a static code analysis tool. JS Hint, I know me personally, I use JS Hint with my Sublime setup, so I get everything JS hinted when I type. It sort of changed my life to find any issues that I could potentially have with my JavaScript code before it's too late, where it's in production, and then I have to make a hot fix, and it's just terrible. I don't like breaking the internet. Like I said, I work for AddThis, and we're on 15 million sites. So I don't want to make a syntax error in my JavaScript code that breaks your site, potentially. CSS-lint is very similar to JS Hint in that it's going to tell you, is there potentially anything wrong with the CSS that you're writing? So it's analyzing all of your CSS code and telling you, giving you feedback on it. All right, so CoffeeScript. I am not a CoffeeScript fanboy. There are people out there that love CoffeeScript, and it's, a lot of people use it. But it's a transpiler, right? It basically compiles to JavaScript. So that's an example of something that analyzes your code and converts your code to JavaScript. Plato is an example, and this is a visualization, a code complexity visualization example. Arya also talked about this, right? It'll look at each one of your files, and it'll tell you, is this file too complex? Is there the potential for there to be errors? What about the maintainability of your files? Which file is most likely to be unmaintainable? That's an example of a static code analysis tool. All right, one of my favorites, the Require.js optimizer. If you use AMD, and a lot of people do, you probably have lots of different AMD files, and it's pretty common that you want to package up your app or your library into one file. So the Require.js optimizer will figure out your dependency tree within your code, and it'll make sure that all of your dependencies are put in that file in the correct order so that nothing bombs. It's very cool. AMD Clean, so this is the project that I had referenced earlier. This is the project I've been working on. It will convert AMD code to regular JavaScript code so that you do not need a AMD loader. You don't need an AMD shim. Because all it's doing is it's finding your code, and then it's compiling it to JavaScript. We'll look at an example of that at the end. Browserify, I don't want any CommonJS people to be angry with me, so I'll include Browserify. It will allow you to write in a CommonJS format, right? You'll have multiple CommonJS files, and then you'll be able to bring all those, your entire project into one file that can be used in the browser. It's a very powerful technique, and it's another example. It's very common. So, have you used the static code analysis tool? I'm not going to make you guys raise your hands because I'm assuming that you have. You've probably used something, whether it's a minifier, whether it's something like JS Hint. You've probably used it. I have not met a developer who hasn't, a JavaScript developer who hasn't, even not a JavaScript developer. So the question of my talk now really is, have you written a static code analysis tool? So who has? Just curious. I will make you raise your hand. I see one person. One person. Anyone else? Have you written a static code analysis tool? All right, that's what I thought. My assumption was correct. You probably haven't. And so why is that? Why haven't you? I also have a theory about why you haven't. You don't know where to start. I had, just me telling you this, I had no idea where to start. I wanted to create this AMD clean project because I didn't want to have to include an AMD library to use AMD. And I didn't know where to start to create that. I thought, should I use regular expressions? I don't really love regular expressions. They can become very hairy to look at. So what do I do? Like, is there a technique I could use? So I figured something out. Someone on Twitter gave me a hint, and I started researching. And so I want to provide you with the same information. Let's change your understanding about what you can do. So all right, let's get started. Static code analysis basics. Every static code analysis tool needs some input. That input is going to be a string of code, right? This is a very basic example. This is creating a variable, and this is saying this variable called code is going to be a string. That string represents a function declaration called JQCon. So that's simple enough, right? You could do that in your everyday JavaScript land. So the interesting part is when you take that string of code and you convert it to an object that actually means something. If you look at this object, keep in mind this object represents the string that we just looked at. So what does this object tell us? It tells us the type of this string. It's a function declaration, which I mentioned before. It tells us the identifier name. So what do we call this function declaration? Well, I called it JQCon. That's awesome. So did I pass any arguments? Are there any potential arguments to my function that I had in my string? There weren't. So you'll see that params property is set to an empty array. If I had set an argument in my function, it would say, hey, whatever the identifier was for the argument, it would list that in the array indice. So because this is an empty function, there was nothing inside of it, that's what the body property tells you. The body, the nested body, that tells you what is inside of that function declaration. Nothing. Nothing's inside of it. It's an empty array. And like I said, it's a function declaration, which is different from a function expression. So it's not an expression, just some handy metadata to have, potentially. And this object is great, right? You guys are so pumped about seeing this object. It's so cool. It's called an AST, or an abstract syntax tree. So an abstract syntax tree sounds very academic. And when I first heard it from someone on Twitter, I was like, I'm not going to do that. That sounds way too intense. I'm an academic person, but I'm not that academic. It scares people. The reality is, if you're in JavaScript land, which in our talk, it's just an object. It gives you lots of cool data. So it's not scary. I go a little bit more into the abstract syntax tree. It's an object. Trees sound scary. I like thinking of them as objects that represent the structure of your code. So think if that function declaration that I showed, if there was a nested function declaration inside of it, that object would show you that actual structural representation. It'll show you how your code is structured. So part of the name is abstract, and that means that not everything is stored. So syntax stuff. The example I gave was a JavaScript function that it starts and ends with an opening and closing curly bracket. It doesn't store that. It doesn't care. Okay, so that's why it's called an abstract syntax tree. And there's a lot of potential when you have a JavaScript object with a lot of data. which you guys probably already know. It can be traversed and it can be updated. All right, some common AST questions. Again, why would I ever want to use an AST? Maybe you want to analyze your code. If you're in this talk, you might potentially want to use an AST, just a guess, potentially. So, like I had mentioned regular expressions before, and regular expressions are dumb. You can only get so far with them, and they're notoriously ugly. Some people go very far with regular expressions. I, on the other hand, like readable code, and in my opinion, you see a program with lots of regular expressions over and over again, it's very tough for me to read. So how do I generate an AST? That's the question, because that's the part I skipped over. I showed you the conversion, but how do you get there? So how do you generate that object? The answer is you use a parser library, or you write your own JavaScript parser. There's two options. That's usually the case for pretty much anything. Any code that you write, am I going to use code that someone else wrote, or am I going to write it myself? So in this talk, I'm going to go over code that other people have written that will make your life so much easier. So let's generate an AST. Esprima. Aria mentioned this. It is a JavaScript parser written in JavaScript, and it will generate an AST for you. It's an amazing project, and the project itself is a building block for so many other projects. It's really the core foundation of a lot of these static code analysis tools. It's a great thing that you can, Aria follows the UMD pattern, right? So that means that it can be used in both a Node.js or a web environment. You're not limited to just Node, although a lot of my examples are going to reference the Node CommonJS sort of syntax. And it adheres to the Mozilla SpiderMonkey parser API. This basically means what the object should look like. What properties should the object have? It's a standard so that you can reference that standard when you're actually in your code base. You're like, I have a function declaration, so that means I know that there's going to be a type property, and that's going to say function declaration. That's how you know it's a function declaration when you're iterating that object. So it's good. It's a great reference. And like I said, it's created by Aria, who has also made a bunch of other open source things that have been great. Phantom.js being one of them. All right, so let's get into some code. Generating an AST with Esprima. Just like before, I have the same code variable, which is the same string. It's just a function declaration. I'm showing the Node.js style of syntax. That means that I'm just requiring Esprima, the library. So I'm storing the Esprima. I think it's a function. It might be an object. I don't remember. I think it's a function. I'm storing the Esprima function, and then basically I'm storing a variable called AST, which is my AST. And the way that I'm grabbing it is I'm calling the Esprima.parse method, and I'm passing it my string of code. And it's that simple. You have the AST, that object that we first looked at, that's being generated by that Esprima.parse. It's very simple. It's pretty awesome that you can get that easily. And keep in mind, I have all the code examples, or most of them, I have either on require bin or JS bin. So you can go back to this presentation, you can look at it, you can mess around with it. It's up to you, but I'm not going to click on each individual one of those. So that is great. It works. ASTs are so cool. That's what I thought, at least. So I still have a few questions, though, about Esprima. So we just kind of barely talked about it. What are some common Esprima questions? First off, do I have to use Esprima? Like, why? Why am I using Esprima? No, you don't have to use Esprima. I will say it's battle tested. It's been around for a while, and a lot of other modules use it. There are popular alternatives. The one I mentioned here is Acorn, and that's the AST that is used for Uglify.js. Right, so I mentioned Uglify.js as an example of a static code analysis tool, but it doesn't use Esprima. It uses its own built-in JavaScript parser called Acorn. So the other question is, so I heard about this, Mozilla SpiderMonkey parser API. Why does it use that? And I kind of touched on it before. It's really developed as the standard among static code analysis tools. A lot of tools are adhering to this standard. So that's really the reason you want to use it. You want to be compliant with other tools, right? You don't want certain tools not to be able to be used with your library. So you want one format. That's really what you want. And this is the one format that people are really using. All right, so what now? We just generated our AST. What's the next step? Well, let's traverse that object and potentially update it. Keep in mind, if you're just doing analysis, you can just traverse it and get some data about the program, right, inside of your object. That's all you'll need. But you might also want to regenerate code and do advanced things like that. There's a lot of possibilities. So let's look at first how we would traverse our AST. So we're really standing on the shoulders of giants here because I mentioned Esprima to generate my AST, and now we're going to talk about ES_Traverse, which is also a JavaScript library. Now, ES_Traverse provides some pretty badass methods for traversing and updating an AST object. It can also be used in a Node.js or web environment, and it as well adheres to the SpiderMonkey parser API, which is great, right? Because Esprima does and ES_Traverse does, and they all work together peacefully without erring. And it's created, I always try to do shout outs to maintainers of really awesome open source work. And Yusuke, I hope I'm not butchering your name, but he's done a lot of work in this sort of JavaScript realm. So very appreciative of the work that he's done. Makes my life and many others much easier. So let's look at some examples. Traversing an AST with ES_Traverse. ES_Traverse, you'll notice that I'm requiring it just like I did Esprima in the Node.js sort of syntax way. And then I'm using this ES_Traverse.traverse method. And my first argument that I'm passing is my object, which we saw before, is that function declaration. And then I pass an object as my second argument, and I have an enter and a leave properties. And they're both functions. Pretty much the enter gets called. You'll notice that in my enter functions, the node and parent are my arguments. So that means that anytime ES_Traverse will traverse every single node in your object, every single property, and then it'll give you whatever that node or object property is. And the leave it's another hook that you can use. After all the child nodes have been traversed, then the leave property will be executed and it'll pass you the node and the parent of that node. All right, so not only can you traverse, because we weren't doing anything in our enter and our leave hooks, you can also update an AST with ES_Traverse. And the first way you can do that, there are two ways that I know of that you can do it. You can still use the traverse method, and right now I'm only showing you the enter hook. And because ES_Traverse passes us the node, the current node being iterated on, we can check to see what's up with that node. And in my example, I'm just checking to see what the type is and what the name is. So if I had a lot of code, hopefully my if statement, it would only go inside of my if statement if the identifier was jqcon, right? If that's the only function, or if that's the only identifier with that name, that's the only thing going into my if statement. So what I'm doing is, if I find an identifier that's named jqcon, I'm changing that node's name to be jqcon, which is the name already, _is_awesome. So I'm actually changing the name of that identifier in the object itself. So you don't have to use the traverse method. The replace method can be used instead, and I guess it can be a little bit cleaner way if you actually want to update your AST. The only difference, this is the very same code example, the only difference is instead of acting directly on that node that gets passed to me, whatever object that I return inside of my enter function, that automatically replaces the current node. So it's a little bit simpler. Instead of saying like node.name equals, I actually return an object with the different name. You can tell it's a little bit cleaner as opposed to doing string concatenation, which I was doing in the previous slide. Just two different ways. They both work. It's up to you. So this is so awesome. It works. This works too. Traversing and updating ASTs is just easy. This is all easy, like a piece of cake. Like I didn't know this was possible. But what's so great about? All right, so I updated my object. What's so great about it? But before we get to that, I got ahead of myself a little bit. Let's talk about some common ES_Traverse questions. Again, do I have to use ES_Traverse? No, you don't have to. Again, you could write your own, or you could. There's a popular alternative called ES_Query, which uses sort of syntax that's very similar to CSS selectors. It's kind of cool. It's a cool project. I've personally not used it, but I know the person who maintains it, and he's very well regarded, so most likely it's pretty good. This is the question I just asked as well, but couldn't I traverse and update the AST myself? Do I need ES traverse for this? AST traversing is pretty tricky. There isn't a unified interface for each node. So my example here is a variable declaration has nested children within a declarations property, when an if statement is going to have the nested children within a consequent property. So you kind of have to work out, if this, if that, if then. So you have to work out all those conditions, and ES traverse has handled that for you. So it's up to you if you want to do it just for learning's sake, or if you want to make a competitor to ES traverse, have at it. But I myself have not wanted to do that. All right, so let's review some stuff. Sprema generates our object. ES traverse will loop through our object and allows us to update our object. What else is there? All right, we've generated, traverse, and updated our AST, or our object. Let's generate some code. You guys are so pumped. So the next giant that we're going to use is ES CodeGen. ES CodeGen is a JavaScript library that will generate code from an AST. So it's the opposite direction of a Sprema, right? Which generates an AST or an object from your string of code. It's the different direction. We've seen this before. It can be used in both environments, Node.js and a web environment. We've seen this too. It also adheres to the SpiderMonkey parser API. These all adhere to the same format, which is why they can be used together. Very cool. It's created by the same guy. A lot of these really awesome static code analysis tools have been created by similar people. So we need more people to get involved in this sort of aspect of JavaScript programming. All right. Let's generate some code, and this example is very boring, right? So all it's doing is it's generating the AST, and we've left ES traverse off of this example just for the sake of having all the code on the screen without having to scroll. But all it's doing, it is taking the string of code, turning that into an object, and then it's going the exact opposite way by calling the escodegen.parse, and it's turning that object back into a string. That's all there is to it. Like they're very simple APIs at a high level, which is pretty awesome. There's powerful things you can do with this. That is amazing. Generating code from an AST is hot. That is nice. But again, I have some more questions. I'm not so sure about this ES CodeGen thing. Do I have to use it? Everyone always asks that. Do I have to use it? Good question. I don't know, because I'm not sure of a good alternative. I don't know. Does anyone know of a good alternative to ES CodeGen? Anyone? I don't know if Arya's in here. He might be the best person to ask. I haven't found any good alternatives. Let's see. Couldn't I write an AST code generator myself? You can always do that. You can always do that. But I will see you guys next year when you're done, because it's going to take you forever. And we want to get stuff done, right? That's why you use jQuery. You want to get stuff done. jQuery helps in that. So let's review everything again. A Sprema generates an object from code. ES traverse allows you to traverse and update that object. ES CodeGen allows you to have that object and convert it to a string of code. It's really awesome when you combine these three open source projects together. You can make really powerful things. All right, some wrap-up questions. So all my examples have really shown a very high-level API, right? I haven't delved into some crazy things we want to make. Do you have any more complex examples? And this is where I was going to show the project that I've been working on. And I'll point out each individual part that we've learned and how they've applied to this project. So I already have it set up here. AMD Clean is the project I've referenced a couple times in this presentation. And all it does, it converts AMD code to standard JavaScript code. So let's remember, this is the input. This is the code, right? So basically, I'm creating an AST based off of this. I'm traversing an AST, and then I'm using ES CodeGen to print this code on the right, which is supposed to be the standard JavaScript code. So if we actually write some things, the example I give is, you know what? I'm going to make a AMD module, and I'm going to give it a module ID of example 2. Normally, if you're using like require.js, it'll automatically populate that module ID for you. You normally don't want to list the module ID. The optimizer will do that for you, but for the sake of showing this demo, I'm going to create a module called example 2. I'm going to say it's going to depend on my first example module. And then, let's see, I'll give it a callback function. And good, it returned undefined. It returns undefined, right, because nothing is getting returned in my callback function. So I've written all this code with Esprima, ES-Traverse, and ES-CodeGen, and I can do all sorts of crazy things. I can say, you know what, this is an empty callback, so I'm gonna return undefined by default. You know what if we had something in there? What if we return, I don't know, true? That's not true, that's true. All right, so if we return true, it's no longer undefined. You'll see that all my AST logic is saying is, you know what, there's a dependency there. So I'm gonna transform that define into an immediately evoked function. And I'm gonna pass my dependency, and I'm assuming that dependency is above my current module. So I automatically pass it. It doesn't matter if you have more than one dependency. You know, you can have callback functions. It'll change the name automatically. There's a lot of crazy things you can do with code regeneration. So this is a very basic example of a transpiler, right? It's like, think about it. You could write something like CoffeeScript. It's that easy to write something so powerful. This is all AMD clean is under 1,000 lines. It's like 900 lines of code. It's not like crazy amounts of code, which is why I wanted to give it as an example. Because I pinpointed, I gave the website example, but I also listed the source if you want to look through that. And if you go through this presentation, you'll notice this is all very similar. Okay, he's using ES-Traverse, he's using ES-CodeGen, he's using Esprima, and these are all really easy things to do. Imagine the possibilities. Oh, I want to write something which detects global variables being accidentally exposed in my scripts. Like, would you ever write that before if you didn't know that all this technology was there? Probably not. I know I wouldn't. So this has opened up like a completely new world of tools to write. And so it's very exciting. There are more and more tools like this being made. And it's an exciting time. So I was so excited, I want to share it with you. But one other thing is I didn't cover CSS static analysis. I've only been covering JavaScript, right? So you can do this in CSS as well. I had mentioned CSS lint as an example of a static code analysis tool. And so I have 2 minutes left, so I'm not going to delve into it. But what I'll say is I wrote up a very quick example. This is on JSBin. And I wrote up a quick example of how, actually this is on require.bin. A very quick example about how you could, if you're using the display inline block, and say you want to support IE 6 and 7, which don't have display inline block, you want to make sure that that automatically gets generated for you. I just wrote like a 10 to 15 line thing, which will just automatically put it in the source code and then regenerates the source code. So that's an example of I analyzed my CSS code. I created an AST for my CSS code. I traversed my CSS code. And keep in mind, traversing CSS is actually way easier than JavaScript. So don't be like, oh, it's probably, I have to learn new things. No, it's pretty easy. It's pretty easy. So a lot of cool libraries out there that help you. But you only have to use like one as opposed to the 3 that I'm using for JavaScript. But yes, last thing, are there any more resources you would recommend? So when you start getting into this stuff, there's going to be 2 things that you're going to be obsessed with. You're going to be obsessed with the Esprima parser demo page, like obsessed. You're going to be there all the time. I wonder what my time on page was for that. It's ridiculous amounts of time. You're going to spend there, and then you're going to spend a lot of time at the Mozilla docs for the SpiderMonkey parser API. So those 2 things will become your best friends, right? You're going to lose friends. No, you won't. But these will be your best friends. You're going to be using it all the time, and they're great. There's so much help when you're creating programs like this. So that's all I got. Thank you guys for listening, and I hope you make tools like this in the future. Thank you.